Hello. It is time. Almost. All right, am I definitely doing... Am I there yet? Am I on motors? I think all the joints were good. That's gotta be good. That's gotta be good. That's gotta be good. It's gotta be good. Yeah, I think I'm really there. I think I am really there. What did I do last? Music? That's just silent for the first minute. Okay. Yeah, I got the custom. Yeah, those beam joints working. Good. Now, what is next? Motors, of course. All right. Probably the first thing I should do is just get the hardest part out of the way, which I think is calculating these. Yeah, it's gonna be this: the velocity, the error angles. So, because this is already like 2 levels deep, and I probably want to have like some early returns in some cases, I'd like to have a function that I just call and it will calculate this error term for me. So what do I have here? While count part is this index, part list. Probably what I will just do is say the index of the part is what this function obtains, and then it will return to me an error angle. The error angle should only consider the current okay, I mean, I probably need to define more exactly what the error angle is defined as. Yeah, I need to define what the error angle is. So I just say a function, it'll be called calculate error, and it is given the index of the part that is calculating for. This is so it can obtain the part ahead of it and the two parts that are to the side of it. Additional term for the motor target delta. Okay. So for now, I'm just going to assume the method exists. Then I'm going to get this set. So set up motor velocity. Yeah, it's really just computing this bone rotation delta, which is sort of where we want to go. So I need to calculate the velocity as a sum of angle changes. Or I think it's more like I take the angle I want and then I subtract the error. And that's probably how it would go. So I will just leave that like that for now. That's all I need. And then I calculate a total desired thing, which a target rotation, which is the rotation I want to apply. And it would be I want to say my rotation delta minus my error. That makes sense to me. So that would mean to take the inverse of the error. Hi, Danilin. Whoa. So that's the target rotation. This is the rotation that I want to achieve. Now, I'm going to assume that I only have a single axis of freedom. So what I can do here is I can just, using the axis, I mean, I guess I have this. There's motor axis. Motor axis is resource rotation axis. I guess I can calculate it up here too. I'm going to organize all my files today, put together. All I've done is remove all the test stuff. Organize. Nice. Yeah, I know that it shouldn't change as I go. Blast this one. Danilin. Would you just wait? Would you just wait? Let me like... You know how getting into like the zone like takes a certain period of like unbroken focus? What is this? That's so loud. No. I can't say I agree with that. I want to support all rotation. Okay. I mean, if I have to calculate it every time, I guess I may as well just run it through here. It would be nice if it was a simple calculation. And I do actually have a nice way to fix that. The IK does. If I have the axis, I take that rotation, I apply it to the axis, and then I calculate the rotation back to the axis, and then I apply that to the target rotation. Wow, some people just know how quaternions work. I mean, I feel like I could have, honestly, that one I feel like I could have figured it out if I was just really thinking about it. Because it's not even that crazy. It's not like an insane idea. It seems like it's such a simple idea. So the axis will be I would need the actual skeleton bone pose rotation. So this one I can actually calculate up here then. All right, if I can calculate it up here, I can get that axis. Hmm. Stop stressing about Godot, get on VRChat and spend the day talking with furries and all the sane people from there. No. No. I'll pass. All right, let me just say there's only one axis allowed. Also, don't I have to enable? Don't I have to enable the motor? I have to enable the motor. Yeah, if flag enable motor. I don't even have it enabled. All right, I guess I do it up here, right? So I get the axis that I'm rotating on and then I enable that. I just wish there was a way to define the axis specifically, like as an index, so I'm not doing branching, I'm not checking two ifs. It would just be like, oh yeah, get the axis using this index. Set the motor using this index. But I can't because they're crazy and they're like, oh, let's do get flag X. Let's do set param X. Psychopaths. Honestly, I'm like kind of suspicious that there's not like heavy amounts of LLM code in Godot's source engine. I feel like the amount of things that I see, something must be fundamentally wrong. The way that functions like get node and like get node and then get node or null existing, this to me is like a crazy insane anti-pattern. Just that these two functions exist. To get a resource UID, resources have a unique ID, but this is a resource scene unique ID. To get the actual, like if you want the string, which is what exists in the file of the thing, you have to do resource UID, ID to text, and take an integer, and the integer is read from resource loader. So you have to load, you have to open disk and access disk for this ID every time. You get the resource UID, but it gives it to you as an integer, and you have to provide the path and not the resource. And then the resource path is a member named resource path. Why is it prefixed with path? There's not like a path or a name on it. It is just they named it resource path. So the engine knows what the ID of this resource is. It does. It just knows it. That's how it references it. But it's not on the resource. So you have to ask the resource loader for it. But the resource loader doesn't go into the cache and grab it. No, it opens the file from disk, reads the string, parses it to an integer, and so I have to convert it back into string. Why does this not just give the string? Why is it not saved on the resource? Why? Okay, it can't be saved on the resource. We need the master class to manage the IDs. Okay. Grab it from the master class. That gets it when it loads it, because resource loader loads the resource, so it reads that file to know the ID of the resource. Joint limitation cone 3D. Why would you make an API 5 files wide for what is essentially 3 lines of code of a single implementation? I'm just so suspicious of this. The more things I see, the more things just don't make sense. An AI would create this. Hey, I need a limitation resource. Okay, I've modified 6 files. Here's your resource. Here's the abstract API. Like that's what it would do. And it's like, I didn't ask for that. In fact, why did I ask for a resource in the first place? Just set it as the angle and then an offset. People can't be this dumb. Even if someone was stupid enough to write that code, the fact that it got put into the engine is unbelievable to me. Like at least 2 different people who moderate the PRs looked at it, at least 2 looked at it and said, this is good. And in fact, the whole IK thing, that was like a meeting. I found the PR. It's like the biggest comment chain I've ever seen. 130 comments. It's kind of crazy. I didn't read it all. But I was like, something's not right here. Apparently the whole thing was implemented in one go as well. It was a one-shot. Okay, he one-shot it. PR's open. Here's 20 files. Here's some spaghetti monster. They had a meeting. They looked at the code. We like the design. No, you don't. You don't. I don't believe you. You didn't look at the design. Any amount of scrutiny, this design is terrible. No resources. There was one resource, but it's such a weird usage of the resource just to store a single float. And there's no alternatives, and you can't extend the resource. So why is it a resource? It doesn't make any sense. They must all be stupid. Like, either they're all stupid. No, actually, never mind. That's a guarantee. No matter what, they're stupid. I just wonder, was this a language model who wrote this code? Or are they just continuously that stupid? Do they have one person who's thinking? Not even that. Do they have one person who's thinking and is talking? It might be like the kind of rot that pervades the game industry, or at least strongly pervaded it a while back. It maybe still does, but I think it's being corrected now. Toxic positivity. You can't criticize it unless it doesn't work. If it doesn't work, then you can maybe point out the bug, but you got to be really nice about it. If it's just the worst thing you've ever laid eyes on, you got to be like Let's get that PR in there. Let's nitpick some style changes. Just to act like I have a conscience, but I don't. Oh, it's such a big project. There's so many PRs. We can't keep up. Then don't keep up. It just... You don't have to. All right? Whatever you put out there, make it good. Godot's like the strongest quantity over quality code I think I might have ever seen. Like, at the end of the day, it has to work, so at least it has that going for it. It can't really have many mistakes. But design mistakes, those don't affect the execution of the code. That doesn't affect the result. It makes it horrible to use and really, really dense to understand if there's a mistake, or if you think there might be a mistake. God forbid I wanted to write my own IK and make use of any of this API, this huge, expansive API that's totally inaccessible for some reason. There was but one resource, and it was just to store a single float value. Wow. I'm gonna keep complaining about that until this game is done, honestly. Things are piling up. I'm finding the skeletons in the closet, and the skeletons keep falling out. Okay, what do I need? I need to calculate... I really just need to have this one axis. This axis can be pre-calculated. I'm gonna make the requirement that motors are single axis only. They don't operate on two axes. If you want to, you have to have two motors. So that means I can definitely obtain this axis up here. So I can get bone rotation. This is what I applied. This is what came back. So end minus start is the change. So this would be the end times the inverse times the end. So start, it'd be like the inverse start minus end or whatever. Or I guess they think of it as like negative start plus end. So this is where it is now. Though it is a bit annoying that I have something called bone rotation, so let me just say like ooze, I guess. So there's that, and then I want to get the bone rotation axis. It will be a vector 3. And this is the axis I have to correct for. And I just get the rotation axis. And then if this ever gives me an error because it's out of range or something, then I need to fix it. In fact, I suppose I can check here. What is this? Iterate IK3D rotation axis. This is an error. Physical bone art. 3D, yeah. Also, I feel like this one's such a silly thing too. Everything being a 2D or 3D, even though there's cases where it literally doesn't make any sense to call it 3D because it only exists for 3D and you would not use it for 2D. Or even like the presence of APIs called 2D, which are documented as just being the 3D version, but with like the z-axis set to 0, then what's the point? Just make it that. We don't need to add 3D or 2D to everything. And what happens when you typo it? I mean, you have to just rely on like a typing system to save you from typing the wrong number of two numbers that are next to each other on every keyboard ever. Why don't we call it a quaternion 3D, huh? Why don't we call it that? How about a vector 3 3D and a vector 3 2D? Why don't we have those? Why don't we have the basis? Oh, we actually do have the basis 2. No, we don't have the basis 2D. See, this is a case where it actually makes sense. A basis can be 3D or 2D. You can use it for both. I mean, they say 3D rotation. Oh, actually, no, never mind. Because a transform 2D is literally just an angle and an origin. I forgot. Oh, this is a scale and rotation, technically. But really, in 2D, you have one rotational axis. I'll let it fail later, but I'll just error there for now. Well, I'll let it behave strangely. Because what's going to happen is it's going to use this axis, and the axis is going to be like 0 or something. And it's going to try to rotate a 0 thing, and it's going to be complaining about that. Just set an axis there. Okay. Now I have the axis. So I take target rotation and I'm going to clear it. I rotate the bone rotation axis. And then I get the angle between that and the bone rotation axis. And then I correct the target rotation. And this will fail here if this was a 0. Which it should be... Wait, I listed as a... Yeah, it's a vector 3. Okay. So now I have the target rotation. And then I would then just calculate a velocity from there, which I think these might be fine. I do have to do for improving the calculation. Oh, right, and then I have to do this stuff. There could be some kind of Boolean call here to check this, but that would only be possible if these were parameterized by the axis instead of defined by the axis. I can do this. Yeah, and setup. Because I specifically want the setup to enable or disable that motor. Can't I actually do this here? Because I update motor torque. Should be powered is powered and not broken. If they're the same, we stop. Yeah, okay, so that's kind of not then what I'm looking for, is it? If the part is powered, or if the part is not powered, oh, I stop. Okay, so solve velocity is supposed to calculate the velocity of it, which means I actually have to set that velocity to 0. Which it seems like I've forgotten to do. Why do I check should break twice? Oh, these are custom joints. That's right. These are the custom joints. Of course. Should break still needs to have that signal that calls out. Oh, it's right here. I already do it. If break use signal should break is false, call that, and then I return that value. This is to update motor torque. I'm actually going to call it just update motor instead of update motor torque. Joint data is destroyed. It means that we've deleted the joint, so I don't actually have to update the motor anymore. Okay. Instead of checking that, let me check if I have the bone joint instead. If I still have the bone joint, then I can update the motor. And what I will do is when I'm toggling, I have to set the velocity to 0. If it changes, I have to set it to 0. If it is not changing, I don't have to set anything. Yeah, okay, this makes sense. So this return's still fine. And then down here, in fact, I'm taking all out completely. I'm going to say that this should only be on one axis. And in fact, I'm just going to go change resource rotation axis right now. Oh yeah, it's only 3. I can only do 3. Wait, rotation 0. Well, oh. I'll add none and make it 3. There we go. So now I don't want to check iterate. I don't want to check this anymore because it's not what these are. This is specifically 0, 1, 2, or 0, 1, 2, or 3. Then I'm just gonna have the same error. And then I'm actually changing that error, yeah. Well, I don't know, let me say like... Let me say that. And yeah, this is what I'm toggling, so I don't have to do anything. Okay. So if motor axis is equal to 0, I'm setting the torque limit on there. I'm gonna like clear everything. So I want to set... Let me just please write code. Stop. Set these to infinity, I guess, or maybe just 0. In fact, I will clear everything in one go at the top so I don't have to duplicate so much. That seems better. So always to 0 and then turn them all off. I guess I don't really have to set the torque limit, do I? I only really have to set it on the thing that I'm enabling. Yeah, I guess so. Now, am I thinking of this right? The joints should be aligned so that... Yeah, so that Y becomes the rule and then X and Z become that. Okay, good. Yeah. I just want to check that they're actually aligned. They obviously should be. Don't save it. So yeah, X and Z are going to be most common, and then otherwise it's the Y-axis. And then I'll note okay, so if it's the same value, motor power will be started at 0, false. So then it will turn on. Yeah, okay. So we'll turn on, and this will run through, grab the torque limit, and then turn all the motors off, and then turn on the one, and then set its torque limit. All right. So now it doesn't have to be turned on here, it'll be turned on up there. So now I have target rotation on the axis that the motor can apply. Now I just have to calculate the velocity of that. And target rotation should just encode the angle itself. So how do I get the angle out of a quaternion? Because I think that's all I need to do. Two times the a cosine of W. Okay. What does Euler do then? It makes it a basis and then it calls get Euler. Okay. Now I get to play the game of where is that? Yeah, that's got to be way worse, right? I see a bunch of A tans and division. Branching. Okay. See, I think I just ask for the angle here, and then that's the velocity that I'm applying, right? So this should still be yep. Should be good. I want to remind myself what inverse does. What does inverse do? Wow, that's really simple. Yeah, okay. Whoa. Let me try to think about this. So let's say I want to reach 2 degrees. And my error tells me I'm at 2 degrees. That should then mean the motor should do nothing, right? The motor says, well, I want to go to 2 degrees, but my error term tells me I already have an incurred error. I'm already incurring 2 degrees. So then it does nothing. I think there's a torque problem here too. I think when the motor wants to reach a certain angle, or when the motor wants to apply velocity, it should turn on the torque. When the motor does not want to apply velocity, it should turn off the torque. Right? But then there's the case of it wants to stay fixed. And so it turns on torque. What does that mean? What would be the case for that? I think it just should always be the case that if it wants to be at 0, then it would turn off. Or it would effectively lower its torque. Because that velocity is like a target velocity. Maybe then the problem is that the calculation isn't necessarily saying I want to be at 0, it's saying I want to be at the velocity that I would be incurring. Maybe that's the issue. Do I need to look up something with robotics to figure this out? This has to be like some kind of general engineering problem. Because I feel like there's something just here that I'm not getting. Hello, Rig Dev. Thanks for following. Because I think that is a case where if the motor would effectively be obtaining a velocity because something else is rotating it, then that should be its target velocity. Wouldn't that make sense? How do I know that? Again, I think it's the case where if another, due to just how the joint is set up, this motor is going to end up getting a rotation of 2 degrees. And that is also its target rotation. This calculation would say, okay, so the motor should stay at 0. But that's not true. I'm more calculating a change in velocity, right? I say the motor should not change its velocity. So then how do I know what its velocity is? Its velocity, I could say that its initial velocity is what I would calculate from the rotation error plus what it is now. I think that's it. I think I'm calculating a change in velocity. I think that might be it. I say my motor velocity is going to be whatever I calculate from rotation error plus its current velocity. And then I calculate my target velocity. I say, all right, that happens to be the same now. So then I say, all right, well, that's my velocity. Okay. That seems like what it is. So this is not how this is used up here. So I'm just going to replace this with, well, I'm just going to say targetation is that. So I can just put this here. I'm just going to explain it. I use comment. Yeah, I'm just going to write it down. Why is that an underscore? I don't know why. That doesn't make any sense. Wait, so is this... okay, now I'm confused, because now this just means I would ignore that. I would just ignore this completely and say, yeah, whatever, I don't care. Here's the velocity. So how does that work? Does this mean I don't need it? Well, I guess the question is like, what if I don't have a desired velocity? Right? Well, then that just stays the same again. I just say my velocity should be 0, regardless of what the error is. But then my idea with having the error there is because if I know that I'm going to incur a velocity change, if I'm going to incur a velocity, then I need to counteract that specifically. So it's not enough to just say I want to stay at 0. It's to say I need to move at -1 to counteract what's happening to me. So in that case, it would be like saying my current velocity is 1 and my desired velocity is 0. So then I apply the change to my velocity. So I calculate that change from these two values, and that is my velocity? No. But then that seems correct, right? If I want to stay at 0, I have to actually counter what is being applied to me, which in this case would be, I mean, let's just say like we're in rotations per second or whatever. 1. 1 rotation per second is going to happen to me. So I should do at -1. Right? And the current target, this is the important part, the current target velocity. So if there's no error, my current target velocity is 1. I calculate my desired velocity to be 0. But that doesn't mean I apply -1. That would then mean I say, here's where I want to be, here's my current velocity. It's because what I'm doing is I'm setting the target velocity directly. But then it still makes sense to me that if does it not actually make sense? Do I not need to do this? Is this an overcomplication? Maybe it's more like this. I calculate this change, which includes this added thing. And then I add this change to the current target velocity. So now this is where the true thing has applied effectively. So my current target is 0. My error is +1. My desired is 0. So I calculate the change as being those two put together. So it would be -1. Then I get the current velocity is 0, and I add -1. So I end up with a resulting target velocity of -1. I've adjusted for the error now. Let's say the error goes away. My current target is -1, and my desired is, my current velocity is -1, and my desired is 0. Calculate the change. It's +1. So then I say -1 plus 1 is 0, and this is the new target velocity. So now I get both. If there's no error, then the equation doesn't change. I'm just literally setting the target to what I want it to be. As soon as an error appears, that starts to be factored into the target. Okay, I think this makes sense. Okay. Now the question is, what should the velocity be? I think the velocity, I really need to include the fact that I have the location of this joint on the body and what that velocity does to the body. Or rather that the joint is acting on two bodies at the same time. And what changes that angle between them. So I can calculate the angle I want to be at, and I should be able to calculate exactly the kind of velocity that would get me there. That's more like that's more about, though, the minimum, I guess. Which I don't think I have I think this is the minimum. Yeah. Okay, let me make the assumption that I know what the desired velocity is. So I'll just start running through this. Um, let's do this stupid stuff. Yeah, I just need to have this. How can I do this? I'll just do this up here. No. What is it? So I guess I can check which one of these is enabled, but I don't want to do that because that's like probably really a much worse lookup than just saving the value when I calculate it the first time. So I'm just going to save plus rotation axis, and this will be axis vector. Very annoying. These are just kind of stupid names. Okay. Now, true velocity is going to be some sort of maybe I can just calculate ahead of time exactly what this velocity is instead. I can calculate what that velocity is. And then the errors can be that velocity as a I think that might be better. Give me this motor velocity plus the rotation error, and then I calculate a target velocity, which will just be something. This target velocity is now where it gets into math, or physics math. I mean, yeah, I think the idea is I kind of do it like this. I determine what velocity could theoretically get me there in a single go. So, and I know I'd be applying it as a rotation to a fixed point on two different bodies, and I know that location, because I have the data. I have exactly where I'll be applying it. I have the mass. Wait. I would need the physical body state, which means I need to access the body from that. Joint data. I have the parent. So these are the two bodies that this will affect. So I have my body, which is this object, and then I have the parent. So now I would obtain... I need to get the physics. I'll just do this. Yeah. So then I need to figure out, I have the change, which is the angle. I can also get the axis. So I know this axis, what is it relative to? Is it an absolute? The axis is relative to the joint itself. So the assumption I make is that I assume I need to create this amount of rotation, which means oh, there's also true velocity, actually. I forgot about that. I said that sentence totally wrong. There's also the existing angular velocity between the two bodies, which I think comes from rotation error, actually. Yeah, rotation error should come from that. So the chain will calculate if there's already a rotation between the two. And this is where, yeah, here's the thing. Let me think about that. So I want the motor to be, I'm at the angle. Let's say I want to travel 2 degrees and the two bodies are already rotating that like that. They're already rotating. So I say, all right, so true velocity and desired velocity, that's a change of 0. Ooh. That's not right. Because what I should say is the motor velocity should then become 2. Because otherwise it's going to be trying to target 0, which means it's going to be stopping that rotation between them, which I don't want it to do that. I want it to keep that rotation between them. Which I guess in that case is more about like control of the torque of it, right? Maybe that's where this comes in. If I determine that I'm at the velocity I want to be at, I drop the torque down to 0. If I'm not at the velocity I want to be at, I increase the torque to the target or to some target amount. That is exactly what it should be doing. So I say update motor, which is calculating a torque limit and then applying it directly. But this is more like, it's not really a torque limit, but it's setting the torque of the motor. So if I say I'm at 0, I want to drop that torque down to 0. If I have any amount of change, then I want to increase that torque up to the max using some like acceleration value. Let me look this up. There's something here that I'm looking that I hope I can see. That might give me something about this. They're talking about torque as a change of as the change of velocity, which is effectively the acceleration. The force of yeah, whatever. So torque might even be like, in this case, I could interpret as just being the acceleration. Hmm. Didn't really give me what I was maybe looking to find. Because yeah, torque in the case of like what this really means is how hard it's going to try to reach the target velocity. Or yeah, that. Which means I need to interpret that, I need to apply it as if it was the acceleration. So if I don't want to accelerate, my torque should be 0. If I want to accelerate, I would have to set the torque to something. I think a good way to do it might be to effectively use this as like an accelerator. So I have my max torque and I have an acceleration that I can apply to that, some sort of acceleration rate. So if I calculate that my inherent motor velocity is 2 and I want to go to 0, then I say, all right, I set my target to what the target should be. So that in that case, it would be like -2. And then I set the torque to be, I start increasing the torque. Effectively accelerating it, right? This is like my accelerator control. So if I calculate that my desired change in velocity is 0, then I say, all right, let's start dropping. We need to drop the torque. We don't want to do any acceleration. So this, I think I can just probably delete that. And there's not really a good reason to... It's kind of not a good reason to continuously calculate it here, but I would sort of have to. And then it seems like I have to do it in a smarter way, that solving this several times with the same delta doesn't cause the whatever acceleration rate for whatever rate of change I determined for the torque doesn't like amplify. So I suppose that means I would have to do it up here. I would have to say, I have to save the torque that I'm at. And then this is like the baseline that I can modify up to some. So every time in here, I calculate where I want it to be, and then I set the value on the motor to be that change. And this is more like friction mode. I feel like I should probably just set, like, call something friction mode. Which just means I won't be... And in fact, yeah, I feel like it's probably here. And then I'll just assume I'll just say this drops to 0 every time it toggles. Even though it may not be totally accurate if it were to turn on and off. But these things should really only turn on once and then turn off once. So I set that to 0 every time it flips. And then I guess the idea is... And then I want to set target velocities. I think torque is always setting to... No. I'm saying like a torque limit here. So let me actually just bring this all the way down, I think. Ah. If we are powered, we go to 0. Otherwise, we're going to this, and then I would just set that on everything. And then I think I'm also, am I just always zeroing the velocity? I think I am. So I turn everything off. I turn on the one that I want to use. If we are not powered, we go into just some fake friction mode, which is just setting the torque to something and then setting the target velocity to 0. And then otherwise, we are powered. The torque would be reset to 0. Velocity also just reset to 0 every time. So now in here, I will calculate an initial torque. And I have to figure out which one it is. Dude, if this was just a function, like, literally if the guy tried to use it at all after writing the API, he'd be like, you know, that sucks. Why did I do that? I can't even comprehend how you write an API like that in the first place. Angular drive torque limit. And it should be made a parameter, I guess, for the resources. But then I have to define that in so many places. Yeah, honestly, each one of these sections should be resourced. I think I said that I was going to make those resources, but I kind of don't want to right now. So I guess I'll just have a constant up here at the top. How fast can it change? It should probably be able to change really fast. So I might just say 100. Because that would mean I can go, if I have the torque limit set to 30, that would take 3 frames to ramp up to that value. Or actually it would take 30 frames, 30 physics ticks to hit that value. Because every physics tick would add 1. Because I have 100 ticks right now. So that might even be too slow, honestly. I might need to make that like probably double or triple. And yeah, I'll do that. So what I do is from the initial, I calculate what the torque should be, which is either just going to be 0 or the maximum amount. and then I move towards it using this value. So I'll just say change in velocity. Says this for now, and then I will say if I still want it to be like a relative scale, because otherwise it'll be like, if we're really close to the velocity that we want to be at, then I would like torque to be decreasing. I'd like it to kind of like let something happen. Or maybe it's more like, you know what? Let me see. Let me look at something. Because this is a target velocity, but there is an internal velocity that the motor is actually running at. I want to know if I have access to that. I mean, I think ideally I would just be applying an acceleration and it'd be a positive or negative acceleration. So whatever the velocity is and whatever I want it to be, I would just change that. That would be way better, probably. Angle constraint part. Motor rotation constraint part. Oh. What? Wait a second. How did I forget that? Wait a second. Because there's something here with this. Yeah. This is odd. That's a... Hang on. No, I'm not so sure. Because I remember looking at... And I tried it and it worked. Where you would set the orientation and it would use the motor as a spring to reach that. But it would use that as a spring. Which means there's some things that are kind of, there's some considerations there that are harder to calculate. Like I can't really say a max velocity. I have to calculate out a maximum lambda using like calculating an effective mass out of it every time, which is just based on the masses and the locations and the location of the joint on the two bodies. And that you can use that to calculate what the limit, what the velocity can reach. But you can't really specify how fast it gets there. I guess that's the stiffness. Yeah, I guess you still define the stiffness and then you define like the maximum amount. And I think I just got like a message that this was implemented too. Part of it. I think this is related to it. This is it? I don't know. This has got to be mentioned somewhere because it's closely related to this one. I think it was at least. Yeah. There it is. And it's already been merged as well. So this. So I set the target and then I set Um, I have to set, I think, I don't know. This was part of it. Wait, did they already? No, I don't remember. This is still this. It's just needed a rebase because that affected some things. Well, it was mostly just messed up because it was putting in lines of code at the same place that the Angular target was putting lines of code. I'm trying to look for a spot where wherever this is. Here it is. Angular target rotation. So then does this force limit, it says it supersedes what? It just supersedes force limit. Does this set? I want to see exactly what this is setting. Probably gonna be able to find it easier here. Modules. Constraint settings. I see no spring. Frequency damping. Limit? What? And why is it frequency and damping instead of? I'm gonna assume that one's not actually what's being set, and it's doing this. Is it is it this? Does it use that? That's what I want to know. Motor settings, spring settings. Motor settings are what? Great, they're just called motor settings. Then where does that come from? Motor settings here. Spring settings. Okay, so spring settings are purely the... Okay, right. And then we have torque limits. Calculate, this should be initializing them or setting them up with that constraint then. That limit. Here. Wrong place. Here. Motor settings set torque limit. Okay, motor settings. Set torque limit. M min torque limit. Where is it used? There. Okay. Okay. There. So now looking at angle constraint part. Spring part get bias. Wait, why does angle constraint bar such a simpler thing than the other ones? There are way less methods here because there's actually... Wow, what? What? There's actually a crazy amount of templating that happens in somewhere else. And here it's just dynamic. Here it is. Here's the inverse effective mass. This was like 4 template functions. Not an exaggeration. Calculating this lambda, 4 template functions stacked on top of 4 calling functions. Like I'd write the code, it would match a template, and then that template would match another template. Like there's templates on templates. Holy crap. Okay. I mean, if I can set it as a target orientation, that would definitely be better, because this is constantly that goes all the way down into the solution, and now I don't have to do any the motor would be perfectly handled for me if I set the orientation. Alternatively, I get a couple attempts at the start to maybe calculate what it probably would be best, and then this would come in here and do like the 16 iterations of the same thing over and over again. Which means if I was wrong, because obviously I'm gonna be wrong, yes, the 16 velocity steps, right? Which is what this is doing. But this will continuously check, hey, what's our position at now? Or like, it calculates this rotation error, which I don't know, maybe it's not actually that much better, because this is effectively what this is doing. Yeah, it's actually probably not, because yeah. It doesn't exactly. And plus I have the issue where I can't actually control the velocity in this case. Okay, yeah, never mind. I won't be using it. I must have considered that at some point and said, yeah, I can't use it because I can't control the velocity. And because it's not actually, it's doing it one time at the start. That setup is called one time. And then it calls the iteration however many times I set it up to do. Here I have an iteration loop where I try to determine ahead of time what the velocities will be by assuming they will incur certain rotations. Is that not the same thing? No, because I'm constantly recalculating that error. Like, I mean, it's even like the exact same name. Rotation error. It's calculated one time, and I am recalculating it every iteration, which I'm just doing a couple of them. Then add on top of that I'm changing the torque. Yeah, okay. Or what did I get stuck on? How do I determine what the torque should be? I was thinking velocity delta is either going to be an add or subtract. Do I need to have an initial? Yeah, I actually have to also have an initial motor, the initial motor velocity. This has to be calculated up here. Because the delta means well, I can also track it as how this one does it in a lot of places is that it keeps a lambda, and I even saw it. The lambda here is calculated as being the delta time multiplied by the force limit. So this is where I factor in effectively that change. I don't know, maybe this one's actually not. What? Wait, what is that? That's actually strange. Now that I think about it, should a delta time even be here in the first place? Because here I would actually like to continuously obtain this value. I don't want to continuously obtain the value because if I say that my change should be -1, then I set -1 and my rotation error was 1 and now my true velocity is 0, and then my velocity changes to say don't change it because I like it where it's at, and then I start dropping the torque, which is not correct because my actual change is still -1. Yeah, okay. So I still want to set it, but I want to save it the first time. So I'm essentially recalculating the delta, and then that will result in a change to the rotation error of my neighboring parts, and those will recalculate, which will come back to change me partially. So we just keep refining this. We keep refining the new target velocity and or the new change velocity and thus what the torque should be. So I just still want to calculate like what should the torque be. Hi Yelia. How's that? It's good. Um, I think I might be saying this the wrong way around. Yeah, either way, I still have like a new, there's like a new torque and a new velocity. How about you, Yelia? I think it actually, Okay, hang on. I think I'm getting it. I'm getting it. So it is sort of like this, where um I calculate the desired, and I say the torque delta can't be, or has to be clamped to this range, and then determine a torque that can be low when velocity is close to the target. It is kind of like a damping, isn't it? Is it just a constant value? I feel like there's probably just some sort of constant value where when I'm like more than some number of degrees away, or more than some rotation velocity unit away, my desired torque is max. And then once I get within this threshold, then it's like a linear slope. Or maybe it's like a square. Inverse square? Yes, I calculate the desired. The torque delta is going to be limited to the acceleration times delta up here. So delta is end minus start, so it's going to be desired torque minus motor initial torque. So if desired is smaller, then this becomes a negative value. And then velocity delta. And somehow need to limit this so that it won't cause me to exceed a max velocity value. This is gonna be like radians per second. So let me say, what would that be like? Radians. The IK, I think, is given 270 degrees per second. So, I mean, I guess this would just be pi. Which is pretty fast. Can I rate? I feel like he's going to tell me no because it's a function, but it seems like it's okay with that. All right, cool. That's nice then. I guess because it's just a, like, effectively a globally, like a static function, global function. So we can do that. So I guess it's more like this. Well, let's say that I limit desired velocity up here. Okay. So now I'm calculating these values. Then I think I return... I guess I return true if torque delta or velocity delta are positive. Hmm. But I guess it's more like, did I change them, right? Is this a different calculation than last time? I guess this is where like the lambda would be then, right? These would actually be saved over time. And I modify these values. Check that. Insert. Insert. What? What's the point of this? Question I get all the time, what disc you're using? I have Arch. Hello, Soul Ready. What's the point of this? This is literally just adding spaces. This might just be adding spaces. I don't know if that's cool or not. This is what they call self-modifying code. It's adding spaces. I wonder how they do those. And I guess that's how. All right. They're interesting, but I mean that example was definitely just a very compacted Pong game, which was just modifying spaces. You can write that code however you want. You just have to include the part that will add indentation after like characters that are safe to have spaces put between them or put before or after them. With a special exclusion for those characters being in the quotes that you gave. But then otherwise the program can look however you want, or be written out in whatever way you want. Okay. So return applied velocity step. This is just, I guess, a zero check. Yeah. Love Godot, by the way. Good choice. There are things I like about Godot, and there's a lot of things that I don't like about Godot. I will say I like that the scripting is here, and it's kind of, it's a simple language, I guess. I don't have to deal with pointers or crazy stuff. You may complain about AI is good at finding bugs. You can find bugs yourself. And I definitely disagree. It's not. That even fits my metaphor. I don't know if you heard it. The librarian who just goes to the back, grabs a box full of books that look like what you asked for, and then brings them all back. it just kind of spams you with a bunch of stuff, and then you have to figure out if those are real bugs or not. And then it does a really good job of convincing you they're real bugs. So if you're not really paying attention, it's like, oh, this one's a bug. I'm like, no, I know that's not a bug. You get bugs enough with this in your game. Yeah. If anything looks weird, it's a bug. Man, Sheriff, you are, I think. I'm pretty sure you are. We did this test live. You actually watched me do it. I gave it some code that I knew had a bug in there because I wanted to see if it could locate it. The first one, it didn't find it. It gave me about 6 things that were not actually bugs. And then the second one, I refined it. I refined the prompt to try and help it as much as possible. And it gave it as like the 4th option. It mentioned that. Like, hey, I finally got it. So it's not. And like I said, that was a bug that I had spotted just by reading the code myself. They both gave me like 10 things. None of them were bugs. And I think it even got me too, because I was like, oh wait, is that actually a bug? And then I started really paying attention. I'm like, actually, no, that's not a bug. But it nearly convinced me it was. How do I get lambdas? This delta. Effectively, I'm saving the delta. And then the delta is the limiting factor. Well, the velocity delta maybe not. I definitely have to save it every time, so I'll just save that. And then the setup. This is specifically looking to see if I have changed the change. So does that mean they reset it to 0? No, they have this. Which I feel like this part's a bit odd. But I guess, yeah, I guess that still maybe makes sense. Yeah, because it is the maximum change that I can make. But then velocity is a bit different because velocity is I'm not checking to see the change. Well, I'll check to see the change, but I'm not using that as the limit. This one's weird. Okay, so I assume that I have these. I calculate the change that I want to make. And then I would calculate because I think if I do it this way, then I can keep reading back in that same value. I don't have to cache as an initial value. All right. Taking that away. I'm not calculating the initial values. I'm obtaining it every time. And I'm limiting it by this. So then the torque is to be limited so there's the accumulated change, which is that. I calculate the new value. I clamp that. So there's a new value. And then in velocity's case, it's clamped here. This is the limiter. Torque case, the actual change is clamped. So I have lambda, and then I have new lambda, which is this is lambda. What? What? This is lambda. That's what this is. Or not. This part's what's kind of throwing me off. here is how total lambda is included in that. So is it just going to be desired torque minus what I have? Okay, I've got it. Target. I'm going to start rewriting it. So torque delta is going to be desired torque minus that. So the one that I calculated, the last value I calculated, so this is the real change, and then I say this will be equal to I mean, I guess this is just kind of that, right? Yeah, I'm going to follow this. Okay. So new lambda is this value, but then I need a actual change, which is the change of the change. Okay, let me just call it like, let me just fit with the naming scheme, and then I will simplify as I can. Why is it mad about this? Ah. Set lambda to be this value. New minus the old. And then I set total to be that. And then I apply using this value. Okay. Right. And then I return if this value is greater than 0. I could also just say this returns true if it did something, which means simply this just is not equal to 0. And this is not equal to 0. So if either one of these are true, then I did something. Okay. So now I'm going to do this up here. And then I don't have a limit to how fast I can change the target velocity. That's handled by the torque. So some of this might be able to simplify a little bit. Where calculate this, I would say right. Is this already correct? Hang on, I just remember now. Because now I'm not including, I may not be including motor torque correctly. So let's say my desired torque is 1. My current change is 0. Maybe that is that right? I feel like that just can't be correct. Minus the change. The value I want minus the change. I think it is meant to be this. The desired torque. So I calculate the change that I want to apply, and then I subtract the change that I'm already applying. And I don't have any limit on this, so this one's just going to be so this is sort of like saying new velocity delta equals effectively adding this back. So this would cancel out here. So that means new velocity delta is effectively just velocity delta. So I'm going to say velocity delta is equal to this, and then I set the value. So I think I actually just kind of take out the middle in the middle part. Yeah, I think I'm probably just doing this. Right. No, because it would be doing all of this. So if new velocity delta is the equivalent of doing velocity delta without that, then I take this off and I say this is just velocity delta. And now it has changed. So yeah, now because it's changed, I still need a new velocity delta, which will just be velocity delta before this change. So I save it. Then I say, here's the real change. And then I save this to that calculated value. So the new torque is still going to be, I think, this plus that total lambda. Instead of just doing that. Actually, no, I think it is still just this. Yeah, hang on. I think it is still just that. Because since I'm writing it and reading it back every time, ooh, okay. I actually kind of wonder if I even care about the torque delta actually changing. Because this hasn't actually changed the velocity, which means it doesn't affect. If the torque is based on the velocity, then I think that one technically doesn't matter. I still have to do this one because I need to make sure that this limit here is applying. But then I'm not actually doing anything unless I change the velocity. Either way. Right. Because if the velocity hasn't changed, then I think that means the torque shouldn't have changed either. We've either already accelerated up, we've already applied the maximum acceleration, or we've applied exactly what the torque should go to. But because the velocity can keep changing, that torque can either increase or decrease a little bit each time. So this is to make sure that whichever way I'm going, the total change every single time I call solve does not exceed this. It does not exceed this value. So yeah, I only care about velocity. Okay. I'm gonna get food now, so I will be back. Get this set. All right, I'll be back. I'm back. I've got food, and I'm going to eat. I can look at this. Do I need an effective mass? I know I needed it for springs, but maybe that's specifically a spring-only thing. I am pro Akatsuki. What is that? So effective mass is calculated. And it is this crazy. But it looks like I just take the world space axis and I dot it with, I think this is just the inverse inertia. These are axes. I think it's by taking it's taking the inverse inertia tensor and transforming the axis. So I have to calculate the world space axis, which is just the body local axis. I take the joint's local axis and I transform that by the body's transform. I believe that's essentially what this does. Then I take the axis, I dot with adding them together, and that's the inverse effective mass, and I take that 1 over to get the effective mass. And then this is the part that then I have to calculate. Well, I think it's more about the error term. This is like how I would calculate the error term. Not actually the target velocity. And then this, I think, is effectively, yeah, calculate the difference in the angular velocities, accounting for what the motors will add. Or no, sorry. I just calculate the difference in velocity between two bodies. And then I add up. This is subtraction, but here I would basically be adding the calculation for what the velocities of a set to the motors and what they will do. I just kind of wonder now if this was the main error that I made originally. I didn't incorporate the fact that the motors would add velocity, add angular velocity to the parts themselves. And so the motor would say, oh, hey, we're at 2, so let's stop. Or the bodies would start rotating and actually, yeah, maybe I'm not so sure. Okay, well, I'll be right back. I'm back. Okay. Hi back, I am DD. Okay. All right. Can I stay awake for this? So, sort of what I want is that this error is what? A velocity. Though it is not necessarily true that it makes things a little bit complicated in that this does only apply to that world axis. Could you please, if dev0 of equal dev your drive here? What? I don't even know what that means. Poser. I'm not posing at all. I just said I don't know what that is. I don't know what that means. I can't even think to understand what that means. Is that like deleting a driver? What is that? If dev0 of dev your drive. What? Still, like, what could that mean? Did you just make that up? What? What are you saying? What does that mean? Like, I don't know what of is. What is of? And also dev0. What is dev0? These are not quotes. I've never said either one of those two things in my life. I've never said those sentences. So I've been saying the rotation error should account for only the chain knows this part's relationship to all the other parts. I need to know both of these at the same time. Okay. Sortation error, I think. Well, okay. What am I really trying to calculate here? I'm effectively trying to calculate an angular velocity that I want this body to have. This body has a target angular velocity. Technically, it doesn't matter about where you rotate an object by. It just matters if you are rotating the object there, at that location. So, when I say target velocity is effectively just saying, what's my velocity now? Where would I like it to be at? And what velocity reaches my desired angle the fastest? Or I guess in a single step. So if I say that I need to have 2 degrees, I need to travel 2 degrees, then I need my angular velocity to be 2 degrees per tick, effectively. That would then be limited by the maximum velocity, but that's the idea. So whatever the angle is what the velocity should be. Divided by the delta. So this one's actually really, really easy. I probably don't even need body state. So desired velocity is going to be... Also, I don't even account for true velocity. Right. I think it's actually meant to be... Yeah, because this incorporates motor velocity, so I think my problem down here is that I should be saying true velocity. But then I add it to velocity. Police will never find you if you never tell them where you are. Thanks for the tip. So this true velocity accounts for specifically, okay, what is the rotation error? The rotation error is the difference in angular velocity between the two bodies that this one connects, in addition to the angular velocity imposed by the joints on the two other ends. So I read the velocity of those two joints and I say, all right, that also contributes here. Dandelion? You relax? Just calm down. I don't even know what I have no math and I'm a scream is. I thought that was just a joke. Like a meme phrase. Posing for what? What am I posing for? Fake nerd. I don't care about Digital Circus, and I did not know I have no math on my screen was anything other than a meme phrase. All right, let me figure this out. Well, let me treat this because I know this is right. Determine a true motor velocity by adding blah. Calculate the desired velocity, blah. Calculate the change of velocity. Add this change to the current target velocity. The current target velocity. Calculate the change, add it to the current velocity. Finally, drop your mask and say what we all knew all along. Who are you on the right stream, man? Like, some wires get crossed and you're actually talking to someone else, but I'm getting the messages. I gotta pull it up.
Who are you talking to right now?
That was way too long to find that. Anyway. Whoa. I just got that feeling like I just jumped into a pool and got water on my nose. That's crazy. It's like the feeling of a sneeze, but there is no sneeze. All right. So now desired velocity is going to be I think it's literally just the angle limited by the max. And I do fix it down here. Well, I should probably fix it up here instead. Oh. But I need this. I gotta go find it because it's gone. Oh, why am I not there? Here we go. I just deleted it. Reminded me of that. I'll look in a sec. This math, maybe one day I will remember it. I'm looking in the wrong place. Wrong file. This. Velocity divided by delta. Which is just the angle over delta. Okay. I haven't seen that. I feel like I recognize that drawing, but I don't know. I think I've ever seen anything. So why is it just angle over delta? Why is it simply the angle over the delta? Because the idea is that whatever I set the velocity to is what will apply. So no matter what the mass differences between the two bodies are, the velocity I set is going to create that angle between the two. One of them will move halfway. If they were the same mass, one of them would move half the amount and the other would move the other half the amount. So then the angle matches. So simply put, desired velocity would just be angle over delta. Hey, Gilia. That feels so simple. That feels painfully simple. Like it can't be right. I think it's just this simple because that's just how angular velocity works. It's not like I'm saying I want to move this body 2 centimeters away. It's like saying I want the angle between these two bodies to be this value. And it doesn't matter what their shared masses are, that velocity will apply as just simply rotating the thing. Because then I think it's from the chain's perspective that it does this stuff to figure out all the extra. 9K in the second day of marathon. It's been a little more than 2 days, I think. Or is this like some update? Since some update. I can't still anymore with work starting now since last weekend. You can't what? Tell anymore. Okay. Wow, I am my eyes are open, but nothing is happening. No thoughts are happening. I'm just totally staring through my screen. Hey Zeke live. Like how the updates so far to save the game as effortless game modes. Not much as the first map, but nighttime. Second, there's an asset flip horde mode. War Chief Zeke? I mean War Chief. Listen to this to improve my IQ. I think you mean the opposite, probably. I need something that I can do when I'm totally unable to even read the code anymore. That girl who thinks you have ADHD makes you pay attention. ASMR personal attention. Yeah, I think that's not gonna help me focus. Ah, yeah, Attack on Titan. Okay, I get it. What could I do? Honestly, I consider like opening up. There's like these 2 really old games that I think are awesome, and they're like really good games because they're like OG mobile games, except they're not super timer based, I guess. You're not literally waiting for a clock. You can mess up my auto. I'm trying to make a program that I custom input multiple input or output to 1. I guess it's, yeah. I mean, yeah, that I have not tried to do any like operating system stuff programming with Linux. What can I do? So I'm like seriously sleepy. I started hating on Linux since I met this ginger guy. Can hear my typing but not my voice? That sounds weird. Maybe it's time for food. I just ate. That's what food does to me. That's what lunch does to me. Minutes after I go out, I get back, I sit down and I have like 5 minutes before I'm like, take a nap and come back. I've done that. Not really a full nap. I just don't want to. I think it's probably just like me refocusing myself is probably all I have to do. Because I feel like I've just figured out that if I just kind of like pretend like it's not there, I'm like, all right, whatever. Do something, and then I can get back. My normal monitor output. Yeah, I don't know. You got a crazy, something crazy happened. Can't you just reboot? And it will just reset everything. Linus needs to pay for this. Torque. I think I want the torque to be like taking the max torque. I need a ratio from 0 to 1. Okay, I'm just gonna go. I seriously can't. I would be at maximum torque. I would be at 0 torque when the velocity matches. So I'm going to say V. It's going to be whatever I want to go to. And then say V0 is the current value. I'll say V1. And these can be negatives. So when these two are the same, I want an output of 0. And I don't really care about which direction it goes, so just... Okay. So now I'm getting the absolute difference between these two. Right? Now, when do I want it to be maximum? I could just say that I thought of this where I just say to square that result. So for small differences, it's very, very small. And then for large differences, it starts to ramp up dramatically. Right. So how do I combine that with the maximum torque? I could just multiply it by this value. So call this T max is 50 something. Then I might do T is equal to I guess the minimum between probably like TM times this value and right. But then the issue is that this means it's maximum until we are within 1 of it. And then it starts to fall off dramatically. And I don't know if that's what I want. That's also in radians, which is sort of maybe a bit weird. Let me have these be pi. Instead, so we're a little bit closer. Right. If it is, this was all problems on the next. Heroin. Norway versus France. I don't. Norway is winning, probably. I just have a feeling. So what is 1 radian in degrees? Approximately 60 degrees. So once we get within 60 degrees per second, which is actually, that might be too much because now that means it's like never going to be reaching the max torque. You gotta be really far away. And also, if the maximum velocity is 1, is pi? Oh, I guess. Oh. This might be too extreme as well. The square. I could instead do a square root. Which still keeps it pretty high until it gets quite close. So it was like the halfway. It's gonna be 20 point a quarter, of course. So what is that? Once we're within 15 degrees per second, we reach half. It seems like it's still too much. I could just double it too. I could do 2 times the square root, which makes it even closer. Then 0625 is when we reach half. So then 4 degrees per second, it's half. Then where does it start at? It starts at 0.25. And 0.25 was 15 degrees per second. That seems better. Double the max torque, take the difference, absolute value, square root it. Min with the max torque. Isn't this close to like a log function? Um, nah, that doesn't seem right. Maybe it would make more sense to use something that has an asymptote at 1 instead. Then how do I compress this like that? Am I thinking of it's like it's the this, right? That's the soft max. I was not looking at chat for a bit there. This word's not good there. What about squaring this? That's also not good. Hmm. This thing is like, I want the max torque to hit eventually. I think there is a function that gets really close really fast. I want something that has like an exponential, it gets exponentially close to it. These ones are like doing kind of the opposite. They reach it at infinity. I want it to like, I don't know, let's try this. I want it to definitely reach it. How do I do that? I want it to be that it reaches it at a point that I specify. And it does so smoothly. And I know what it is. It's like the exponential interpolation. Do I have it? Yeah, I want a curve like this. What is it? Would I just be raising it to itself? Some constant to the power of x? That one kind of does it. But now I have something that looks really odd. Yeah, this one, yeah, so it's exponentially approaching it. So it can actually reach 1 really fast. So let me just start with e to the x, I guess. How did I make that other thing? I did +1. Do -1. So then how do I make this so that it... Do I put constants here? No. What? Ah, there it is. And then I want to... It's close. But it needs to be 0 at... Or... I think rather I would say x minus 1/2. No. How does this work? What's wrong with this? There's a site that is just these animations. How did I find it? I think Godot links it. Looking for the curve function. This function. Is it called easing? There. how can I get this? Man. Do I just want the sign? Two to the power of 20 times x minus 10. Why is that? Seems like it's still not right. Probably just is this, right? What was this? I don't know anything about it. Pi. Why the negative? Just do... Interesting. So then what is 1? X squared. Yeah. Which degrees a day? It's crazy. But I gotta convert it. And then I'm not gonna try to... You can figure it out. It knows. It's the hardest word to spell. Yeah. So I'd be at halfway at 0.25 and then maximum at 0.5. It's 30. 2.5 is 15. Oh, they do have tau. I haven't tried that yet. I can just type in tau. Okay, so I might say this is the thing, and then multiplied by this whole term. Okay. There's the function. Okay, can you just please tell me what it is? Torque powered. Um, yeah, it's gonna be the difference between these two, right? So I'm actually getting motor velocity delta instead. desired torque is a small value between torque powered and torque powered times. I mean, if I'm no multiplying it like this, then I can just put this as 1 multiply at the front. And or I guess you can just put it at the end. Yeah, okay. Tau times the absolute value of the motor velocity, min with 0.5. Would, I guess, like I could square this at this point. But I don't think that may not do what I think it does. Yeah, that has come the opposite effect. Losing people to heat. That's crazy. Seems like this is it then. The only thing missing now is the rotation error. Which technically, if I don't calculate it, then this should still all... And this should work without calculating it. It's just not going to do anything because rotation error is not going to change every time it solves. So yeah, what happens if I run it right now? Ah. Just count that light out. Interesting. Interesting. They don't want to do anything. Why do they not want to do anything? Just tick a few times. Definitely did set up, right? It definitely did set up. So that means I should have 2. Okay. Bone rotation delta is like nothing. Why is it nothing? Oh, I would expect it to be nothing, actually. I actually would expect it to be nothing. This is for the femur, which femurs aren't really doing anything. The tarsus and the tibia, I think we're going to have... Those ones should have something dramatic. Also, I guess at this point I should probably turn on Should go to the legs and turn on the debug for these. Debug on. Show me the rest area. Show me the step target and the IK targets. And then sure, step reason. Why not? Because this should definitely be doing something too. It should be trying to like fit its legs back. I'm waiting to see a step. Okay. So there's a step. Whoops. It seems like the targets just kind of aren't moving. Floating. You're floating? You're not floating. So trying to move this leg right now. Okay. Trying to think why I wouldn't. Seems like it's just not. That IK target should be like a little bit away from the thing, but it's not. It's like it's not doing anything. So it's the front left leg, so it should be the first leg. So what's happening is step target. It's calculating a step targets. Step transform. Update target. So then we do all of this. So I guess I'll just hit a breakpoint here. Step current, step goal. So that is quite a big move there. Current distance is 0.5. Step delta. New step. This seems weird. I think it's because step current and step goal don't, yeah, they don't account for Y values. New step is this value. Step change, we want to move up and back. Right, so why don't we do that? This is from Skeleton Advance. Am I drawing it right? Am I drawing it in the wrong place? I think I'm drawing it in the wrong place. Pose updated comes from IK. Alright, so I don't know why I need to draw it there. Though it still doesn't seem like it's moving yet. One second. Yeah, I don't know why I specifically have to render it there. Yeah, I should be rendering it after I calculate where I want it to be. Okay. So this update is called from... No. This calls from... Physical skeleton modification processed. If enable, I cache. Otherwise, I do that. If enable, if I have this, run the cached, or run the pre-update. Check earlier step and then I update. Man. I might need to stop. like that, man. I don't like... Okay. I'm just way too tired. I gotta stop. Okay, well, thanks for watching. I'll be back tomorrow to continue this. Goodbye.